Okay, number 2 is the permutations of cuttings out of n things, or arranging cuttings from n things. The first one was the permutation of n things out of n things, but now is the permutation of cuttings from n things. Please note that k is less than n. Any ordered sequence of k objects taken from a set of n distinct objects is called a permutation of size k of the objects. Again, it reminds you the line and the queue. So, arranging, ordered are keywords for permutation of cuttings from n things. At first, we are going to select co-objects from n distinct objects, and then we write all of the ordered sequence of that co-objects. Now look at here. We have 3 distinct objects A, B, C, but now we want to write all the permutations of 2 out of 3. 2 permutations of 2 out of 3. Okay, it means at first we should select 2 items. Okay, if we select A and B, then we can write any order sequence of A and B. It's A, B, B, A. Then, if we select B, C, any order sequence of B and C is B, C, C, B. And finally, if we select A and C, any ordered sequence of A and C is A, C, C, B. Permutations of 2 out of 3. It means it's the lines or queue of 2 objects. Number 3, combinations of cuttings from n things. It's selecting or choosing cuttings from n things. It's a keyword. Given a set of n distinct objects, any unordered subset, ordered sequence, unordered subset of size k of the objects is called a combination. It reminds you group. A group of co-objects out of n. Here it's a line of co-objects out of n. So, in this example, if we want to write the combination of 2 out of 3, okay, it's just group unordered. The first, we should just select 2 from 3. Okay, it's any unordered subset. The first subset is AB. It doesn't matter you write AB or BA. The second one is AC, and the third one is BC. It's group, and this one is line. look at this slide. In this slide you can see the differences between permutations and combinations more clearly. Here the first, arranging coatings from endings, selecting coatings out of endings. Look at these keywords, arrange, select. The first difference, arrange, select. Because of these keywords, here order is important, here order is not important. When order is important, it means 1, 2, 3 is different from 2, 1, 3, and ABC is different from CAB. But here, because order is not important or order does not matter, then 1, 2, 3 is the same as 3, 2, 1. Or ABC here is the same as BCA is the same as CAB. Now look at these examples. Pick 3 people out of 10 for 3 posts, a vice principal, manager, and product developer. So, okay, if I picked A, B, and C, it means A is vice president, B is manager, and C is product developer. But if I picked CAB here, it means C is vice president, A is manager, and B is product developer. You can see the differences. So ABC here is not the same as CAB. Imagine if you were A, here you are vice president, but here you are manager. It's the big difference. Now look at this example. Pick a team or group of 3 people out of 10. Again, keyword, team, group. So, as I told you before, if I give a project to Jack and Mari, it's the same as a situation that I give a project to Mari and Jack. So for a team work or for a team or group, order is not important. So it's a combination. It's the combination of 3 out of 10. But here it's the permutation of 3 out of 10. Now example 2. 2 out of 5 people gets ice cream. 1 gets vanilla and 1 chocolate. Okay. It's again order is again important here, because if we choose A and B from 5 people, then A can get vanilla and B chocolate, or B vanilla and A chocolate. So order is important here again. But look at here, 2 out of 5 people gets ice cream. It means we just should select a group of 2 people out of 5 people to give them ice cream. And the order is not important here. Okay, in this slide you can see the formula for obtaining permutation of k out of n and the combination of k out of n. Again, permutation In permutation, the keyword is arranging, ordering, order is important. In combination, the keywords are selecting, choosing, group, and the order is not important. But in both of them, the sampling is without replacement. Please note that the sampling is always, for both of them, is without replacement. But the number of permutation of size k that can be constructed from n distinct objects is p k out of n is n factorial over n minus k factorial. And for the combination, the number of combinations of size k that can be constructed from n distinct objects, where order does not matter, is c k out of n, and also we can use this notation for combinations, is n factorial k factorial n minus k factorial. Again, in permutation, order is important, and sampling is without replacement. In permutation, order is important and sampling is without replacement.